Hi, Atticus, can you hear me?
Yeah, I got you.
All right, cool. Oh man, you got the Lego room going on again.
Yeah, I can give you all of that, all of
What?
that. It's pretty
That is
crazy.
amazing.
Yeah, Derek loves his Legos.
Is this an adult or a
Yeah, well, yeah, he's a sophomore.
complicated? Is that the Taj Mahal back there?
That is the Taj Mahal. Yes,
What in the world? That is amazing.
it's pretty crazy.
There's this show called Lego Champions, which is fairly awesome. I don't know if you've ever seen that. Have you ever seen that show?
I've not seen Lego Champions.
Wow. I bet your friend has seen it.
Have you seen Lego Champions, Derek?
Oh, you mean the Lego Masters thing?
Uh,
Or that might be what he's
yeah, he's seen it.
No, I hadn't. I have seen some clips of it though.
Okay, he's seen some clips of it.
Oh man, it is awesome. It's intense.
Yeah,
So
sounds intense.
uh so I mean I don't ever know how many people are going to show up for these things. So do you have any
Yeah.
suggestions?
Um, let's see here.
Did stuff kind of make sense for the most part?
Yeah, everything's making sense pretty well. Um, one thing I one thing I was working through some of the distribution problems, like the negative binomial distribution, and
Okay.
on Excel, I'm sometimes confused whether I'm supposed to use cumulative or not cumulative. Like,
Right. Okay. Yeah, so you just have to be
so
careful with that. I mean, so like can you give me an example of when that confusion has arisen?
um it was I think I was working through the one problem about the basketball players that we did in class. It
Oh,
was like I couldn't I knew that I was supposed to um I knew that it wasn't cumulative just because we did it in class, but I couldn't remember why.
so that was the free throw shooting.
Yeah, the free throw shooting problem.
Uh, blah blah blah. So
Like,
well, let's see. Where I'm not seeing it right now. Oh, it's the first problem, right?
yeah.
An excellent free throw shooter attempts several free throws until she misses. Okay.
Mm-hmm.
If P equal to 0.9 is her probability of making a free throw, what is the probability of having the first miss on the 13th attempt or later? Right. So we did that one, right? So
Yeah.
um so so basically you define x to be the negative binomial. So x, if x is the number of free throws until a miss, right?
Mm-hmm.
Uh that's actually geometric. All you're doing is you're just keeping track of the number
Oh,
of that's actually geometric because you're not like keeping track of more than one miss. You're just saying, okay, how long
yeah.
does it take to miss one time?
Yeah. So R would equal 1 in that case.
Right. Yeah, that's exactly right. R would be one. And what would success mean? So it would be a geometric with probability of success, but success here is like you're waiting until she misses, right? So what's
Yeah.
success in this case?
So that would be 0.1.
Yeah, right. 10%. Yeah.
Yeah.
So then, right, so the first one is like if P equals 0.9 is her probability of making a free throw, what is the probability of having the first miss on the 13th attempt or later? Right, so the 13th
Mhm.
or later. So that's, let me just go like this for a minute. So that would be like the probability that X is a 13th attempt or later, X is greater than or equal to 13, right?
Yeah. Yeah, that makes sense.
Didn't we figure out that that just means, I mean, you could actually write down what all of these things are. So that means, that means that she had 12 failures and then a success. Yes.
Hmm. Yep.
So 12 failures and then a success. And by the way, what's our P here? I mean, I know so what's P? What's the probability of success?
It'd be 0.1.
Yeah. Okay, so you had 12 failures and a success.
Uh-huh.
Or what else could happen?
Uh,
You could have 13 makes,
oh yeah. Yeah.
and then what?
And a success.
Right? So do you see what's going to happen here? Right?
Okay.
It's going to go on forever.
Yeah.
So this is equal to, look, I mean, I can factor out q to the 12th times p, right?
Yeah.
Q to the 12th times p. And what's left behind if I do that? There's a 1 here,
Mhm.
plus what would be left behind here?
That'd be a Q. Yeah.
Yeah, plus dot, plus, well, then it would be a q squared, right?
Yeah.
Just so you see the pattern more clearly, plus dot, dot, dot.
Yeah.
Okay, so and 1 plus q squared, etc. That's just, remember the geometric series, it's 1 over 1 minus q. Yeah,
Okay.
so that's just 1 over
Gotcha.
1 minus q. So you would end up with q
Yeah.
to the 12th, q to the 12th times p all over 1 minus q.
Yeah.
But do you understand? 1 minus q is just p, right?
Ah, gotcha. Yep.
So what happens to the p's?
So the P's just cancel out.
Yeah, they just cancel. And so you just end up with q to the 12th,
Okay.
which is just 0.9 to the 12th.
Gotcha. That makes sense.
So you could have computed that with and by the way, when you see this, you realize, oh man, the only thing that survives, it's going to be like the same argument. If I had like a 17 here, for instance, if x equal to
Mhm.
then 17, the only thing that would change is this q would start at 16 and then 17,
Mhm.
etc. Does that make sense?
Yeah.
And then
Yep.
and so if this was 17, then the answer would be q to the 16. And that
Yeah.
makes sense. If x is equal to or greater than 13, all that means is that I had 12 failures. And then
Mm.
whatever happened after that. Is that
Gotcha.
so that
Mm.
really kind of makes sense when you think about it. So all right, so 0.9 12. The other way you could have computed this is you could have just said, here, let me stop sharing that. Let me share something else. Okay, let me bump this up. So let me share this. Okay, so here's this. You see this?
Mm-hmm.
So if I want the probability that x is greater than or equal to, what was it, greater than or equal to 13?
Mm-hmm.
Okay, oops. Just labeling this. This isn't really computing anything. It's just a label. So equal to, you already said, what distribution is it?
It's a negative binomial.
Yeah, it's a negative binomial, but it's,
It's a geometric.
right. So, and okay, so how many failures do we have?
We would have 12 failures.
Yeah, so hold it. Here, let me do this. So this is the same thing. This is equal to 1 minus the probability that x is less than or equal to what?
To 13.
Well,
12.
yeah,
12,
less
yeah.
than or equal to 12, yeah.
Yeah.
Okay, oops. Shoot. I'll put quotation marks around this. Doesn't actually try to compute it. Does that make sense?
Mm-hmm.
So I go equals. The reason I did that is because I want to use the cumulative distribution function. Equal to 1 minus, you said it was negative binomial distribution.
Mm-hmm.
How many failures am I going to have? Like,
Well,
it's the probability that the number of free throws is less than or equal to 12. So how many failures am I going to have? If x is 12, that means it took me 12 free throws to have the first success, yes?
mm-hmm.
Means how many failures did I have?
You'd have 12 failures?
No, not 12 failures.
No.
Because the 12th, if x is less than or equal to, so if x is 12, that had how many failures? So 12 is the number of free throws she took till her first miss, yeah?
Would 12 be considered successes, or
Yeah,
are we
yeah.
talking?
Well, the 12th one is a success because she missed it for the first time, yes? So
Okay.
let me delete this for a minute. I'll just say, 12. So the first success on the 12th free throw means what? For success on the 12th throw
There are
means
11 failures.
She made the first 11 and then missed the what?
The 12th.
Yeah. So that's kind of the key. All right. So,
Okay.
Wait. Okay. So we go equals 1 minus negative binomial.
Mm-hmm.
And what do we say?
The number of failures would be 11.
Yeah. Because failure means make a free throw here. It's kind of backwards, but. And how many successes?
1.
What's the probability of success?
Be 0.1.
And since I want the probability that x is less than or equal to 12, I really do want it to be cumulative, right? I'm going
Okay, because you're adding up the probabilities, like
yeah, because I want okay, if I want x to be bigger than or equal to 13, that's the same as 1 minus the probability that x is less than or equal to 12.
Mm-hmm.
Means she could have missed on the first or the second or the third, and I'm just adding all together.
So if it was the probability that x equals 12, then it would be,
Zero.
it wouldn't be cumulative. Yeah, it'd be 0.
Yeah.
Okay.
Yeah.
Gotcha.
So, so if I go like that, I get that number, right?
Yeah.
Which, by the way, is exactly the same as, let me just go back to, let me go back to the whiteboard thing I was doing before. It was 0.9 to the 12th is what we had.
Yeah.
0.9 to the 12th.
Yeah.
So that thing I just got should be the same, right?
Yeah.
Is it? So let's
Yeah, it's the same.
0.9. Yeah. Yeah. Okay.
Cool.
Makes sense.
Yep. Yep. That makes sense.
Part B is basically the same. It says if she continues shooting until she misses 3, you know, what is the probability that the third miss occurs on the 30th attempt? On the 30th attempt.
Mm.
We're only talking about, it's not like at most 30 or at least 30. It's saying on the 30th attempt.
Okay. Yeah.
And so what does that tell you? Are we wanting cumulative or not cumulative here?
We would want not cumulative at that point.
Right. And this is a different random variable, right? So if y is equal to, you can still see my Excel thing, right?
Yeah. Yeah. I got you.
If y is equal to the number of free throws until the third miss, then how is y distributed? Y is distributed as, that's going to be negative binomial. So what's r here? What's the
That'd be 3.
yeah. And what's the proportion of success?
It would be still 0.1.
Yeah. So, and again, success means miss a free throw, right?
Yeah.
So that's just kind of bizarre. So if I wanted the probability, that, what do I want? The probability that y equals, what are they asking me for? Probability equals
30.
30.
Yeah.
Then that equals what? Well, it's going to be, I just do negative binomial. And this time, so how many failures are there? Those are
That'd
maybe,
be
what's that?
27.
Yeah, 27, yeah. And then the number of successes, which in this case is the number of missed free throws, that's
That'd be 3.
3. 0.1. And
Yeah,
this, I want it to
0.1.
be cumulative?
No, you don't want to be cumulative.
Right.
Okay.
There it is.
Okay.
It's in the back of the book. Probably, but just want to make sure. Yeah, 0.0236. Yep.
Cool.
It's kind of tricky to get the hang of it first, but it makes sense. Makes sense once you play around with it a little bit.
Yep. Just got to get used to it.
All right. What else?
I think that's about it.
The
All the
lectures
new
make-
stuff.
Did you?
Yeah, the new stuff is making sense.
That's good. That's good.
Yeah.
Yeah. Yeah.
So,
Like I don't ever know how much detail. Because I'm getting literally no feedback.
yeah.
So I don't know how much detail to go into. I mean, sometimes I go into maybe too much detail, but that's why we have these sessions so people can come and ask and
Yeah.
clarify things.
Yeah.
Well, I mean, the format seems to be working all right for you.
Oh, yeah. Yeah, the videos are really good.
Okay, good.
Yeah, better than most of the other classes.
Oh, okay.
Um,
So have other classes been doing similar things or?
yeah, Dynamics is trying to do. I'm not sure what they're using, but I don't think they're using Zoom. Um, yeah,
Could
so
you
they're
tell
trying to do videos.
could you tell a difference in quality between Zoom and the
Yeah,
previous one?
yeah, definitely.
Okay, yeah, because I feel like I just have a lot more freedom with it. I can do a lot of different things.
Yeah,
Um, I even think uh, the video quality itself is better. It's not grainy at all.
yeah,
It's just a higher quality product, I think. So
yep,
I once I learned how to do it, and I saw what it could do, it made sense to just go with that full time.
yeah,
So
yeah. It's a neat little software.
yeah, yeah. Well, anything else?
I think that's about it. I'm gonna go eat some lunch.
All right,
So,
Atticus.
thank you very
Take
much.
take care.
Yeah, you too.